Okay, this is an extension for 7.4. So we're going to be working with writing repeating decimals as fractions. So we're going to follow the steps that I have up at the top of the screen. We're going to first write our equation, x minus d, where x is going to be equal to the repeating decimal. So we're basically just substituting in the decimal that they're giving us in place of our d. And then we're going to subtract. It says multiply each side of the equation by 10 to the nth power to form the new equation where n is the number of repeating decimals that there are. So in this part of our video, we're just going to be working with one number that's repeating. So it'll always be 10 to the 1 or just 10. And then subtract the original equation from the new equation and then solve for x. And we will be writing our answers out as fractions because that's what they want us to do. So if we can change it to a mixed number, we will. Okay, so first of all, we have x equals d. Okay, so d is going to be our repeating decimal. So we're going to go ahead and substitute this in where d is. So x equals 0.4 repeating. Okay, so that's our first step. Second step, we're going to multiply each side by the equation of 10 to the power of n, where our n is our number of repeating decimals. So here we only have one number that's repeating. So we're going to take each side times 10 to the power of 1, because there's only one repeating sign, which is really saying times 10. So really that becomes 10x. If I take this times 10 to the power of 1, we're just going to take 0.4 times 10, or in other words, we're going to move our decimal one place. Now, when we do this, remember that is a repeating number. So it becomes 4.4 because the 4 is repeating. Okay, so that was our second step. Now we're going to subtract our original equation. So our original equation was 1x, because it was just an x, equaled 0.4 repeating. So we're going to go ahead and go minus 1x and 0.4 repeating, which we're not going to worry about the repeating sign. So now I have 10 minus 1 gives me 9x equals 4.4 minus 0.4 is just 4. And now to get x by itself, we'll divide by 9. Divide by 9, we just found out that x equals 4/9. Okay, so we're working on converting that. If I were to double check myself on my calculator, let me pull the calculator out. I could punch in 4 divided by 9, and it should give me this answer right here. Pull my calculator back up. So then hit equals, and it does give me 0.4 repeating. So this is just practicing working on repeating, those repeating numbers and how we can actually convert them into a fraction. All right, so let's try another one. Okay, so this time we've got a negative. Okay, so really the only thing that's going to change is when we get into that subtraction part, we have to remember that it was a negative, so we're going to be subtracting a negative. Okay, so our first step is to write out our original equation as, and I'm just going to leave it off to the side here, x equals, and we're going to put this in the back end, negative 0.23. Okay, so our second step is to multiply each side by 10 to the exponent of how many numbers we have repeating. Well, we do have 2 digits, but there's only one of them repeating. So we're going to take each side times 10 to the first power. So really times 10. So this becomes 10x. I'm going to write over here in the middle when I do that. Equals, and when I go times 10 on this one, I'm really just shifting my decimal over one place. So 2 times 3, 2.3 repeating. Okay, then we are going to subtract between them. So, and that was a negative. So here's where it's going to change up just a little bit. We have to remember that when we're subtracting a negative. Okay, so if I write this as this part that's in my parenthesis, I'm just going to shift down underneath here. So minus, and I have a 1x equals negative 0.23. Okay, so 10 minus 1 gives me 9x equals. Okay, so here I have to remember that when I'm doing this, I'm really subtracting a negative. So it ends up kind of being like adding. If you're not comfortable with that process, yes, you can use your calculator. It's going to depend on how your calculator works. So I'm going to have to mess around with mine here a little bit. 2.3, and that's a negative. And then I'm going to say minus 0.23, and that was a negative, equals negative 2.07. Now, when you're working with this, you're going to go ahead and round to your nearest tenth to do this. So if I round this to the nearest tenth, it becomes 2.1. And we would have a negative on that because the larger number was negative. So I have 9x equals negative 2.1. Okay, so now I'm going to go ahead and divide by 9. Divide by 9. Okay, so I can't have a decimal within a fraction, which means I'm going to change that top number to a whole number by taking it times 10 or shifting my decimal one place to the right. So one place to the right is going to make this a 90. So now I have 21 over 90. Now reduce that down to lowest term. So I can see that 3 would go into each of those. So I'm going to divide each of these by 3 over 3, which would give me 7 over 30. And I have to remember I had this negative in there. So final answer should have been negative 7/30. And if I punch that in on my calculator, 7 divided by 30, and I'm just going to remember that it should have a negative in front, gives me 0.23 repeating, and then I would just put that negative in front of there. Okay, very complex. Once again, this is an extension, so it's just something that I'm having you try out.